Okay, so welcome back. Hi, Kamal.
Hello.
So in our previous set of videos, we have come finally to a state where we have been able to demonstrate KubeVault, KubeDB, and a functioning set of application in the form of SockShop and the supporting services that actually make up for SockShop, which are all the microservices and the KubeDB managed databases, let's say. This also kind of puts a spin on what is database as a service. If it's just about deployment, then it's not database as a service. There's more to database as a service. And we saw shades of it from a KubeDB operator standpoint. In this video, we can see that we have the persistent volumes created. We have validated the state of information from an application functionality standpoint, saying everything is working. Note that we have created a test user, and there is a order ID that we had actually created, or it was created to validate the workflow. This is the current state of this application, which, like I said, now brings us to our other question of how do you manage integrity of the database from a from a longevity standpoint. What about disaster and recovery? And this is where yet another product, Stash/KubeStash from Apps Code, makes a lot of difference when it comes to application-oriented backup and restore. So Tamal, over to you. Why don't you walk us through what is KubeStash, Stash, how will it help us?
Sure, glad to talk about it. So as you already mentioned, right, talking about trying to deploy production-grade databases, and obviously one of the important aspects is how do you take backups and how do you restore them. So KubeStash is where you can, is the product to help you with that process. So at its core, I think one of the important things that we have done is that making sure these backups that are taken, those are application crash consistent. Meaning, like, a lot of times people will just take a backup of the volumes and call it a day. But if you think about databases, that usually doesn't work very well, especially if you have a high availability databases. So Stash will take these backups using the database specific tools, right? So it could be like, in case of MySQL, it could be MySQL dump, or it could be a bin log archiving. MongoDB is similar, like it could be a MongoDB dump or like a Mongo upload archiving. Those kind of approaches are supported with the KubeDB, with the Stash. And then the other aspect is that these backups that are taken, we use a tool called Restreak under the hood, which is used to sort of encrypt the data. So the data that is actually going to be stored into this, let's say, any S3 compatible storage or any other object storage, data will be encrypted, right? So you have this extra layer of protection, right? Even if you lose access to that, as long as you have that data encrypted, you can be safe that the data is not out there. And then the other thing is, as that you keep taking this backup, the application data grows. Another concern is how do you make sure that it doesn't grow without any control, right? So there is a concept of like a retention policy. So you can set these controls, like say, okay, keep only for last 30 days, and then it can be very adapted to whatever you need, right? You can say, okay, for the last maybe week, keep a daily backup, but for the remaining 21 days, keep a weekly backup. So all those kind of things you can configure. So making sure that the data that's stored there is available, and ready to restore. And when it comes to restoring, that restore can actually, because we are storing the data into an object storage, it is not tied to the original Kubernetes cluster where the backup was taken. right? So as long as you have access to that backend storage, to this object storage where the data was stored, and the credential that was used to encrypt the data, you will be able to restore to another cluster, which would be in the same region, different region. As long as you can connect to the backend storage, you can restore it. And obviously, you can restore it into the same cluster or in the same set of databases if that's what's required. So that's kind of how we have tried to sort of cover all aspects of this kind of disaster recovery scenarios from a database service point of view.
Sure, and pretty interesting to see, how you can, in a YAML, which is like a few lines of declarative statements, deposit, let's say, we'll be doing it manually here, in the sense we'll deploy the YAML and a schedule will be set for backing up that particular databases. But I can, like a pipeline, build a backup pipeline. Just put this YAML into GitHub or GitLab or a choice of my repository, hook it to Argo, Flux, Fleet, whatever GitOps controller I have, and boom, you have the backups going on.
Yep. I mean, that's the whole beauty of Kubernetes, really, right? End of the day, because this declarative approach, it makes a lot of things really, really easy, and automation becomes really easy. End of the day,
yeah. And I mean, Dell has, like I said, a product of its own, which is more to do with a holistic approach of enterprise data strategy, called as Power Product Data Manager. And obviously, everybody is in the race for this and making sense. But for now, I want to focus on KubeStash, given that very specifically it aligns with the whole app store ecosystem so nicely. And on its own also, it can operate as a standalone or an integrated tool set with the app store ecosystem. Now, before we do that, let me explain to you what we will be doing. We'll be deploying stash/KubeStash. And again, from a licensing standpoint, it will orient with the same license that was used for KubeDB. So that's another additional bonus for us. And then instead of now, you said, right? I mean, there's a multiple backend storage support. So at least, if I'm not using PPDM, at least I'm using my storage. Well, good for Dell. So we will bring in Dell's ECS, which is a S3 compatible storage, an object storage platform. Very proven. Like PowerFlex is being used for block-based, persistent volumes. For object storage, Dell has to offer this object storage universal platform, which has been highly adopted in the industry. And I mean, for all you care, it's a S3 protocol. Yeah, and how you build it out on premises with a highly effective TCO and things like that. So we will bring in this as the backend storage and then hook up Stash with Dell ECS. And like you said, that it's using RESTIC under the hood, we will observe KubeStash doing this database backup and recovery. Okay, and we finesse around how it is being dealt with. Okay, so let's begin by deploying KubeStash itself onto our M2 cluster. Okay, now M1 is basically idling around unless we change the the vaults secrets or rotate them. It's idling around, right? So we'll let M1 cluster be as is. We will deploy the operator for KubeStash. So we go on to the M2 cluster and deploy the operator. Okay. Now, KubeStash has to talk to the Dell ECS storage. And let me go and open up the URL for. So let me close this a little. Okay. Let me open up this URL where I have the host definition for the ECS, and I will take the URL from there. So this is going to be the host for the backend. For now, we'll let it be. Let's first deploy the definitions. So let's check out if our stash has been deployed. So let's see at the stash operator pods. We can see that it's fully running. So next we will build a connectivity with our ECS storage. I'll pick up this definition and put it here. kubectl get ingress minus and monitoring. Sorry. Backup. Sorry. Let me just verify what is the namespace. Okay, it's sock shop. Yeah. So I will get the ingress in the sock shop namespace. So now we can see that our external host, which is our ECS, is also advertised. And I'm going to open up the URL for my ECS storage. Okay, it'll take some time, but that's okay. Now, while this happens, I have already configured the S3 bucket or browser. So you can see this is the S3 browser. It gives me the ability to work with any S3 compatible storage. And if I look at the accounts, ECS, manage accounts. So you can see that this is a S3 compatible storage, not the S3 storage itself actually. Okay. And there are a few buckets already that we work with. And in my previous experimentation, I've already created this particular KubeDB backups as a bucket. Let me delete this particular bucket and show you what will happen when KubeStash starts taking backups. So we have deleted this bucket called as KubeDB-backup, and we will go and work with now the backup and restore operation. Recall that our application SockShop is in a particular state wherein we have, like I said, a order ID, a user, and shipping address and things like that. Everything is basically, so that's the state of the application. And we will start taking backup of this particular application starting from now. In order to do so, everything is declarative, right, in the world of Kubernetes. And likewise for KubeStash, we have a CRD. Now, we will have to do certain things for that connectivity to come true, which means now KubeStash has to talk to this S3 compatible storage. So obviously it needs the access key, the secret access key, the certificate data and things like that, right? It's how you typically would define a S3 connection. So no difference. So it's a compatible storage, means it has to be working in a similar manner for administrators to be, comfortable, because S3 is a standard protocol. So let's take this particular set of commands, and I will build out basically a secret which will help KubeStash connect to Dell ECS. So let's take this here. Okay. And you can see that a secret called as ECS-S3-secret1 has been created. And then once this is created, this is a very important part. A CRD named as repository. Repository meaning the backend storage is what we need to connect to. This CRD is under the hood of KubeStash, which means this object type or the kind will be recognized. If I put in this thing, KubeStash will try to establish the connectivity with the S3 backend storage. Let me take this and put it here. Okay. So now the repo definition is created, which means that somewhere in the backend, if I look at get pods, and did we deploy it in
KubeDB? So if you look at the repository objects, you should see.
Yeah, we did it in KubeDB namespace itself, right?
KubeDB dashboard.
Operator.
So the stash operator is in the stash namespace. Yeah.
Yeah, it's in the stash namespace. Sorry. So let's look at the logs of this particular operator. -n stash. So a lot of things we can monitor here, and I'm pretty sure that somewhere in the repository.go you can see, it has tried to invoke the connectivity and things like that. Okay. Now let's see.
In fact, one thing, if you do like a kubectl get repository, you should see the status like just on the Kubernetes.
Oh yeah, that's the another. So kubectl get repository. Repository is the object.
Dash and KubeDB backup. KubeDB dashboard.
Since there is only one, so I'm just going to say get repository. So we can see that ECS S3 repo is the one that is there. Yeah. Okay. Yeah. Now we will define a backup object through a backup configuration. Let's say that, right? What is a backup configuration? So what we are saying is define a resource type or the kind backup configuration, the name of that in the namespace sockshop, and a schedule of that. So every 5 minutes, we'll take a backup.
Yep.
And the repository that will be used is this, which references to our connection to the S3 compatible storage from Dell ECS. And then where or what will it back up is reference to the app binding for Catalog DB. Catalog DB, note that it's a MySQL database.
Yeah.
Right? Yeah. From KubeDB, we have instantiated Catalog DB as a MySQL database. So we are targeting this particular app binding, and then other parameters. And there's much more to this definition, and you can read it on the reference API reference in KubeStash website. So now, for now, I will take this and create a backup configuration, which will then result into a backup session.
Yes.
Okay. So now we have put in the configuration. It then tries to use whatever has been defined the repository to create what is called as a backup session in the same namespace where the
Yes, it'll take around 5 minutes because we have to 5.
Oh yeah, I forgot. Thanks for that. So yeah, it'll take 5 minutes for the first backup to kick in.
Yep.
So we will pause the video and resume once it's done.
Yeah, one thing I could add is the Stash project also has a kubectl plugin. So you can actually use that there's a kubectl stash trigger command. So you can trigger that anytime. You don't have to wait for, like, if you want, like, not to wait for the schedule to kick in for the session.
Fantastic. And can it be installed regularly through Crew or something?
Yes.
The plugin installation should be simple, right?
Yes, you can. So yeah, we maintain our own sort of Crew index. So essentially, yeah, you connect that and you can use the kubectl Crew to install it, or you can just, these are all Go binaries. So you can also do Carl bash and get it.
Got it. So good. Let's just pause and resume when the first backup has been invoked.
Go to the bucket.
Okay, so it's been 5 minutes. We took a short break. And last when I checked, there was no resources found in SockShop namespace because our schedule says every 5 minutes. So the first backup should have kicked in. And if I repeat this command now, you can see that 2 iterations have happened, or actually the way it works. So we can see the state is succeeded.
Yeah.
Succeeded means that a couple of things would have happened. One, KubeStash is able to integrate with KubeDB. So it's able to validate that app binding, talk to the underlying database, take whatever is required. And second part is it is able to connect back to the repository definition to the backend storage, which is the Dell ECS, the S3 compatible storage, which means as a result of this succeeded operation, we should have seen a bucket that I deleted earlier. So let me refresh this particular list here. You can see that a new bucket has been created called as KubeDB backups. And inside of this will be all the backup related data. And this is every 5 minutes iteration. It will change hands. As of now, the data is persisted with the application state that I showed you, with the order, the user, and this and that. How do we validate this? So we've taken care of the first part, which is we've successfully backed it. Now, let's assume that there is an underlying issue, and the most common method would be to delete the database entries itself, actually, or drop a table in it, whatever, right? So we will do so by invoking a database corruption, in the sense dropping a table. In order to do so, let's deploy adminer, which is giving me access to my MySQL database, wherein I can directly hook up to the database itself and inspect the database entries for the catalog DB. So I will take this particular definition and deploy adminer within my cluster, which will be exposed through a load balancer. So if I say kubectl get service minus in sock shop, rep adminer, let me see here the list. Yeah, okay, adminer, and this has been advertised through an external IP of .60. So I will take this particular IP address and browse into adminer. The database name or the server is catalog DB up. Username and the password. So you can see that I am logged in into the database directly, and there's a lot that I won't explain now, but you can see the important now is this SOX DB. This is where the whole data set exists for my catalog. Now I can drop the whole thing here, or I will go here at the top level and drop this. But before I do this drop, what we will do is we will stop the backup. Okay, let's do that actually. In order to do so, we will just run these two commands so that my ongoing backup is paused, just to make it clean, nothing else, so that you have a visual of how it is looking. Okay, so you can see that when I run the command and say paused equal to true, so you can see that the backups have halted, which means that whatever is there in the state of the application is persisted in the form of whatever backups I have. And now what we can do is go ahead and drop the SOX DB entry. Let me drop this. Yes, we are sure we will drop this. And you can see that there is a success on this, which means the database has been dropped. Let me refresh this and make sure that it's not. Okay. We can see this again from an application perspective by going to the home page. And you can see that because I have dropped the database catalog DB itself, I am seeing a blank page. While everything else might work, the catalog is not available. I can't see any of the catalog products, which means in reality, the database is dropping. This is a classic, I mean, this is a worst case scenario, not a classic, but let's reinstantiate this database through a recovery process. In order to do so, you can see that the CRD is called as restore session. Again, it is taking the same repository for the backend connection to the storage. It is referencing the same app binding, saying that look for this particular database app binding. And then depending upon what the RPO and RTO are and at what point do you want to recover, we are saying take the latest snapshot and then recover. As simple as that. Let's take this particular thing and do a restoral of our SockShop database. Note that the backup has been paused. Okay. Now, what do we watch out for? So when backups were happening, we were watching out for something called as the backup session actually. Okay. Now here, we will watch out for the restore session in terms of its progress. So we can observe the restore session by running this command. It's all good because it says that the phase is succeeded, which means that the catalog DB should have restored the socks DB entry. Right, Kamal?
Yeah.
All good? Am I good to, as a user, to experience that?
Yeah, I mean, let's go to the adminer and see if the database is there or not.
Sure. First, let's look out for the application itself.
Sure.
You can see by virtue of the restoral, my catalog is back in action. Okay. This one, I have to just, because of the cookies, I just have to close this particular session and open one more because it shows stale information otherwise. Okay. So let me 10.204.111.60 and catalog DB. Root, password, and there you have it. Socks DB has been restored, validated in the application. So catalog was available, validated from a Kubernetes operation standpoint of the CRD, which is the phase is succeeded. This brings us to a close of the other dynamic nature of Kubernetes stateful workloads, which is how do you manage the life cycle of these stateful applications. With that, we will do a wrap on this particular video. And in the next video, it's a very short and sweet thing, but we will also we'll do the observability part, like a 5-minute wrapper video on the Grafana and Prometheus integration of how we can visualize this from an operational standpoint and metric standpoint. And there is much more you can do, which we will try to do in the future videos with logging, analytics, with Elasticsearch, Kibana, and whatnot. For now, we will take a close on this video. Thanks, Tamal.
Thank you for the demo.